In this Cisco packet tracer assignment, I will be creating a network for a small college campus which will have a total of 5 separate networks. Individual networks will be set up for the following departments: accounts, IT services, administration, lecturing, and students network. The email and web server will be configured in the IT services network. Each switch will be given a name that represents the network they are on, for example, accounts. For all usernames, I'll be using Cisco as the username and password as the password. I will also show a walkthrough of how I set up security using passwords and how I encrypted all password information. I will then show how to ensure each PC can reach the web server and will edit the web server to display the name of the college. For the purpose of this assignment, each network will use only 3 PCs in Packet Tracer to represent the entire network. After the walkthrough of how I created this network, I will demonstrate testing the network. So let's jump straight in. First, I'll add 3 PCs to represent each network. I will then connect the devices using a copper straight-through cable, which is a standard Ethernet cable used to connect 2 devices that operate in different layers of the OSI model, such as a switch to a PC, which is happening in this case. Also good to note, it can be used with Ethernet, Fast Ethernet, and Gigabit Ethernet port types. I will also be then renaming each PC a name that coincides with its network. Next, I'm going to show you how I configured the initial switch settings on this network. This will include securing access to the command line interface CLI and console ports using encrypted and plain text passwords. I will also configure messages for users logging into the switch. These banners are also used to warn unauthorized users that access is prohibited. So as you can see here, for each switch, I'm creating a basic switch configuration. Configuring a device password, local username and password, setting both console and telnet password, and enable login through the local user account, and encrypting all password information for each switch in the router. The first step is to enter privileged exec mode. You'll see I've already done this on this particular example by entering EN for short, or you can type enable. I began assigning a name to a switch. To configure a name for a switch or router, use hostname command from global configuration mode. To access this mode, simply type the command config-t as you've seen in the example, or you can write configure terminal. Following on from this, the next step is configuring an encrypted password to secure access to privileged mode. I did this with the command enable secret password. I then went on to securing the access to the console line, and you can see this where I access config line mode using the command line console 0 and set the password to password. You'll also notice on each switch and the router that I'm configuring, I then also typed the command login local. And the way I like to remember this from research and reading about it is that the word login is just one word, and when you use the command login, you need one piece of ID to get in, which is a password. And then login local, which is two words, you actually need two pieces, both the username and password, to gain access. After this step, I encrypt the enable and console passwords using the command service password encryption. I then moved on to configure an Motd banner. The Cisco iOS command set includes a feature that allows you to configure messages that anyone logging onto the switches see. These messages are called Message of the Day or Motd banners. Enclose the banner text in quotations or use a delimiter different from any character appearing in the Motd string. I used the command banner Motd and made a sign indicating authorized access only with stars in front and then the hashtags before and after just to signify the start and the end. And then in each example, you will also see that the final step is saving configuration files to Mvram to ensure that the changes made are not lost if the system is rebooted or loses its power. And the command for this that I use is copy run start. You can also use cop or s, or the long version is copy running -config startup -config. So the steps that I've just ran through are the steps that I applied to every switch on the network and the router. And for the next couple of minutes in this video, you will see me do this for each switch on the network. Next, I'm going to move to the router and configure the initial settings on this network, including securing access to the command line interface and console ports using encrypted and plain text passwords. And I will also configure messages for users logging into the switch. These banners are also used to warn unauthorized users that access is prohibited, exactly the same as the walkthrough I just gave on the switches. So as you can see here, I'm applying the same methodology. So you can see that here I actually start to go into privilege exec mode, then config T. I set the host name as the college router, and then I configure an encrypted password to secure access to privilege mode by typing enable secret password. And then on the next line, I set the username to Cisco and the password to password. Then I went on to securing the access to the console line. And again, you can see this where I access the config line mode, line console 0 and set the password to password, secure the VTY lines and enable the password to be password. And then again, using the command login local, as we discussed before, to prompt for both a username and password when logging into the router. And then finally, encrypting the enable and console passwords using the command service password encryption. And then I move on to the command banner Motd to set my message of the day banner, authorized access only. And very important not to forget this part, save configuration files to Mvram to ensure that the changes made are not lost if the system is rebooted or loses power. And then I can just press exit and you'll see I'm prompt there for my username Cisco and password. Next, I'm going to configure each router interfaces with the given IP address of each network. There's currently no connection, and this is depicted by the red line. We need to know which Ethernet cable a switch is plugged into. You can check this by hovering the mouse over the cable line until you see, like for example, it'll say gig 0/1 or gig 0/0. And if you hover over the router, it will then display the port information and link information, which displays as down at the moment and red triangles on the line, which means that this is the beginning of the process. So first I'm going to click on the router and select CLI. Now we need to enter the IP addresses. Type enable and config T to enter global configuration mode. I now want to get onto gig 00. So enter the command int space g 0/0. So now I'm in config F mode and I'm now on the port in the router. Next, I'm going to add the IP address and the subnet mask using the commands IP add, followed by the IP address and subnet mask, and then hit return. And followed by that, I'll enter the no shutdown command. And once we have entered all the IP addresses, we will then see that the light will go green to show that the line is up, and we'll see the message each time we're adding the IP addresses, you can see change state to up. But obviously it's not going to work yet because there's no IP addresses assigned yet to the PCs. And lastly, we're just going to save configuration files to Mvram to ensure that the changes made are not lost if the system is rebooted or loses power once again by entering copy run start. So now I'm just going to close this and you will see that all the triangles have now turned to green, which means we are up and ready to go. Now that we've configured our router and applied the IP addresses, we also need to configure the switch router with IP addresses. By default, Cisco switches forward Ethernet frames without any configuration at all. For the purpose of this assignment, I'm just going to do the configuration. This means that you can actually buy a Cisco switch, plug in the right cables to connect various devices to the switch, simply turn the power on and it'll work properly. But to perform switch management over the network or use protocols, the switch will actually need to have an IP address. The IP address is configured under a local interface known as the management domain, or a VLAN. Usually the default VLAN 1 acts like the switch's own NIC for connecting into a LAN to send IP packets. So the following steps are to configure an IP address under VLAN 1. So we begin by logging into the switch and enter our username and password, enter privilege exec mode, enter our password as password, then we enter config T. Once we're here, then we need to enter the VLAN 1 configuration mode with the interface VLAN global configuration command. So we type int VLAN 1. Now we're in config F and we can add the IP address and subnet mask using the command IP add followed by the IP address and subnet mask address. We then move on to enable the VLAN 1 interface with the no shutdown interface subcommand, and then we enter the IP default gateway IP address global configuration command to configure the default gateway. And we do this because if you don't add the IP default command to the switch can only reach hosts in the local subnet and no other subnet. So without this command, no other device outside the subnet can reach this switch. And then finally, as usual, I save the configuration files to Mvram to ensure that the changes made are not lost if the system is rebooted or loses power by using the command copy run start. And now I am going to move on to configuring the remaining switches in the network with IP addresses using the same commands and procedure. So next we'll move on to assigning an IP address to each PC in the network. So far we've enabled the interfaces of the router, but the PCs will not yet have communication because we actually haven't added them to a network. So to do this, I'll proceed to click on each PC and manually configure the IP address. So we enter the desktop menu and we just simply enter the IP configuration menu. Just verify that the static option is selected, then proceed to enter the IP address, subnet mask, and default gateway. Just to be very careful that the default gateway must be identical to the address on the router interface and that the IP address and subnet mask must match. And then we can close this window and just configure the other PCs in the same way. Later on, we will check connectivity by performing a ping test from one PC to the other. Now that the PCs are configured, I'm just going to enter the email and web server and configure the IP address as 192.168.0.5. Enter our subnet mask and default gateway. Next, I will configure the web server. I do this by clicking on the email and web server, and then we just click on services. Once we click services, select HTTP, click on edit index, and you'll see all this information here. We just want to remove the majority of it and leave this line here. Replace Cisco packet tracer with the name of your campus. In my case, it's NDC campus. Click on save. You'll get a file warning. You want to overwrite the file. Click yes. Next, we want to configure the email server. So we select email and make sure that both SMTP and POP3 service are both on. Under domain name box, type the domain name as ndc.edu and click Set. I then configure the email username and password for each PC in every network. And you can see the user setup here. Under user setup, you type in the user name and then the password after for each PC. I will then go to each PC and configure each PC for email. So we just open our first PC and we will click on email. So under user information, type the name that you want. So your name can be any name. And then in the mail address box, you type the username that we created in the web server and then simply add at ndc.edu, which is the domain name. Under server information, incoming and outgoing mail server, type the IP address of the email and web server HTTP, which is 192.168.0.5. Under logon information, type the username we created in the web server with the password we also created, which is password. And finally, then we just hit save, very important, close the PC, and then move on to our next PC and repeat the process until we have all the email configured. So now that we've configured the email client for each PC in all the networks, I think we're pretty much finished here, and we can move on now to the steps in actually testing the network. So just a bit of background, ping is a networking utility program or a tool to test if a particular host is reachable. So it's a diagnostic that checks if your computer is actually connected to a server. And the term ping is actually taken from the echolocation of a submarine, sends data packet to a server, and if it receives a data packet back, then you have a connection. The term ping can actually refer to the time it takes for the data packet to travel round trip. It means get the attention of or check the presence of. In a computer network, a ping test is actually a way of sending messages from a computer to another. Aside from checking if the computer is connected to a network, ping also gives indicators of the reliability and the general speed of the connection. A ping test is a method of checking if the computer is actually connected to a network. That's why we're interested in it. It also determines the latency or delay between two computers. So it's used to ensure that a host computer, which your computer tries to access, is operating. A ping test is run for troubleshooting to know connectivity as well as response time. So it's really important that we actually perform ping tests, because we need to check if everything that we've done is working and in order. So I did a number of ping tests that you'll see coming up in the video. So I basically, from the administration network, so I went from each network. So start with the administration network, and I was pinging from the administration PC1 to the PCs on the lecturers network, then the PCs on the accounts network, the PCs on the students network, the PCs on the IT services network, and to the email and web server as well. And then you'll see me move on. I will do ping tests from the lecturers network, ping from lecturers PC1 to the PCs on the administration network, again from PC1 to the PCs on the accounts network, the students network, the IT services network, the email and web server, and then I'll move to the accounts network and ping from accounts PC1 to the PCs on the admin network, lecturers, students, IT services, email and web server. And then I'll go to the students network and ping from students PC1 to the PCs on the admin network, accounts, lecturers, IT, email and web server. And then from the IT services network, I'll ping from the IT services PC1 to the PCs on the admin network, accounts network, lecturers network, students network. And then I will perform some more tests, and look at accessing the web server from each PC. And in terms of just how to ping, we just open our PC1 as you saw, go to desktop, command prompt, and then you just type the command ping and the IP address that you want to ping. So it's really handy to make an addressing table, and it's kind of best practice. It's really helpful just for when you're doing tests like this or entering IP addresses, and you just have it to hand, so you're less likely to make a mistake. So next, I'm going to look at accessing the web server from each PC in the administration network, and then accessing the web server from each PC in the lecturers network, the accounts network, the students network, and the IT services networks. So we're just entering the IP address of the email web server, hit go. You can see NDC Campus comes up on each PC. So you open your PC, click into web browser, type in the IP address, click go, and on each PC you will see it's successful. Our NDC Campus is displaying. This section of our video is going to cover testing our email services that we've configured. So we are going to send multiple mails to various users in each network, in fact, all of them. And we're also going to see the mails being received, just to ensure that all the email is configured correctly, it's up and running. There are many tests, so if you just watch through this video, you'll see me sending all the emails to different users and then going through and making sure that they've been correctly received. So this brings us to the end of our testing and the end of this assignment, creating a college campus network. I hope you enjoyed, and thanks for watching.